Optical fibers. Optical fibers are long, thin strands of very pure glass about the diameter of a human hair. They are arranged in bundles called optical cables and are used to transmit light signals over long distances. A single optical fiber consists of three layers, namely core, cladding, and buffer coating. Core is the thin glass center of the fiber through which the light travels. Cladding is the outer optical material surrounding the core that reflects the light back into the core. Buffer coating is the plastic coating that protects the fiber from moisture and from any kind of external damage. The bundles are protected by the cable's outer covering called a jacket. How does an optical fiber transmit light? Transmission of light through an optical fiber is similar to the transmission of light through a hallway. When you have to illuminate a long straight hallway, you just have to point the beam straight down the hallway, as light rays always travel in a straight line. But to illuminate a hallway which is a winding one with multiple bends, you need to line the walls with mirrors and angle the beam so that it bounces from side to side all along the hallway. This is exactly what happens in an optical fiber. Optical fibers make use of total internal reflection to confine light within the core of the fiber. The core of an optic fiber has a higher refractive index than the cladding, and hence the light suffers total internal reflection. Although the cladding does not carry light, it is nevertheless an essential part of the fiber. The cladding is not just a mere covering. It keeps the value of the critical angle constant throughout the whole length of the fiber. Propagation of light in an optical fiber. Let a ray of light be incident on the fiber, making an angle theta c with the axis as shown here. It gets refracted into the fiber. Let the refracted ray make an angle theta I at the core and cladding interface. If theta I is greater than the critical angle theta c, then the ray suffers total internal reflection. So all the energy in the ray of light is reflected into the core and none escapes into the cladding. The ray then crosses to the other side of the core, and because the fiber is more or less straight, the ray will meet the cladding on the other side at an angle which again causes total internal reflection. The ray is then reflected across the core again in the same manner. In this way, the light zigzags its way along the fiber. Thus, the light gets transmitted to the end of the fiber. Because the cladding does not absorb any light from the core, the light wave can travel great distances. However, some of the light signal degrades within the fiber, mostly due to impurities in the glass. Terminology used in fiber optics. Here you can see a ray of light traveling from air of a refractive index μ0 into an optic fiber. The maximum angle of incidence in air, for which all the incident light is totally reflected at the interface of a pair of media having refractive indices μ1 and μ2, is called the angle of acceptance. Fiber attenuation. It is defined as the loss of light energy during its transmission through an optical fiber due to absorption by the impurities in the glass fiber. Applications of optical fibers. Optical fibers are used to transmit communication signals. In endoscope used to investigate interior organs which cannot be viewed directly, and in photometers.